Alright, so what we've got here is we've got two water molecules, two H2Os. We've got our protons in the stroma space. This is the membrane of the thylakoid. So inside of here is the thylakoid space. Outside here is the stroma. Out here we've got our NAD+. There's two of them there. And now we've got our different electron carriers. This one, the electron carrier FD, is the ferredoxin. This electron carrier PC is the plastocyanin. And this electron carrier here is the plastoquinine. We're going to run through the steps of photosynthesis and the light reactions with this model right now. And you can follow along. Alright, in this first step, we're going to have the photon from the sun. It's going to come down and strike photosystem 2. That's going to cause a water molecule to be split by the manganese complex that's embedded here into the photosystem 2. When that happens, what's going to happen is that the electron is going to be transferred from the water. This is photolysis of the water, the light splitting the water molecule. The electron is released from the water, which causes the proton to be released. The electron is transferred through the photosystem, passes from the photosystem, and then is passed to the electron carrier, plastoquinone. Alright, so that was the first step. Now this hydrogen, this proton, is now in the thylakoid space. Our H2Os here, I'm going to erase this because it's getting messy. One of them has been split. That's the first step here of the photosystem's splitting the water. One electron has now been transferred here. This whole step is process that we're talking about is transferring the electrons through this system, and the protons are going to be built up on one side here. So next, another photon comes down and strikes photosystem 2. That causes the completion of the splitting of the water. The oxygen is going to be held there. The electron gets transferred again inside by the photosystem 2, gets transferred to the plastoquinone electron transport, electron carrier there, and a second proton is held here in this thylakoid space. So at this point, the electron carrier PQ is carrying two electrons, and they're going to carry it to this proton pump. Okay, now the next thing that's happening is we space these out so we can get the idea here, is that these electrons are going to be carried by this electron carrier PQ over to this point here, and as they move this way, it's going to pick up protons from the stroma, carries them to the cytochrome B6F complex. This is a proton pump, and what happens is that one of these electrons is going to be taken out of here and passed through here and carried to the next electron carrier, and in the process, the energy to do that, it pumps out another hydrogen. So that hydrogen, that proton, came again from the stroma and getting pumped into the thylakoid space. You can see we're building up this a little bunch of hydrogen protons here on the top. Okay, now as this one passes from this side, it moves down to the photosystem 1. So our electron carrier PC is going to move from the proton pump that it came from here to photosystem 1. At this point, now another photon from the sun comes down and hits the photosystem 1, and just like in photosystem 2, the energy from the photon is going to excite the chlorophyll molecules, which is going to cause the electron to be pumped through the photosystem, and it's going to pass to the electron carrier inside the stroma. So it gets picked up here as it gets to the other side. Now this electron carrier, this one is ferredoxin. It takes the electron over to FNR, and at this point FNR is going to hang on to it, and the ferredoxin is going to go back here. Alright, so a couple things to keep in mind too. What happened here is that at this point no water is being split here. The water is split over in photosystem 2, but no water is split here. But the energy from the photon is going to give the electron the energy it needs in order to move across here, because as it's gone through the system already, it's been losing its energy. But once it gets here and it gets that boost of energy, the second boost of energy that it needs in order to get carried on to the next stage, where it's going to be carried to the FNR. This FNR stands for ferredoxin NADP reductase, meaning it's going to reduce NADP plus and make it into NADPH. Okay, now the next step is that this all resets itself now that the electron's been carried over. Now we've got these electrons and this proton still sitting in this electron carrier here. What they're going to do is they're going to be pumped just like the first one that got pumped. Proton's going to be pumped into the thylakoid space here. The electron is moved and pumped through the cytochrome complex. It goes through here and gets picked up again by the carrier PC, electron carrier PC, which then carries it over to photosystem 1. And then again, there is going to be a photon of light that strikes here, and again that energy from the photon is going to get the chlorophylls molecules excited here, which is going to give an energy boost to the electron, which then can get passed through to the electron carrier ferredoxin. Ferredoxin is going to pick it up and take it over to FNR, where that other one was waiting. And at this point now it's going to take the NADP and this molecule here, FNR, is going to combine the electrons with a proton from the stroma, and now we have a NADPH molecule, all of them put together inside of there. Alright, we're going to try to clarify a little bit here. What does this mean when it goes from NADP plus to NADPH? What's happening is it starts off as this molecule here, NADP plus, which means it has a charge. That's what the plus means. When you add an electron to this, plus an electron, now what happens is it becomes NADP. It loses that positive charge because the electron has a negative charge. So now it's just NADP. But then we're going to add an additional hydrogen, which has a positive charge. So that would put it back to NADPH plus, because it has a charge. But we add that other electron to it, and it removes the charge. So now it is NADPH. hopefully that helps clarify a little bit how we go from this molecule to this molecule. Something important to notice here, what's happening is that the amount of hydrogens in the stroma is going down. Even though the stage in making this didn't pump any to the other side, the number of protons that were free protons here in the stroma continues to go down, and the number of protons here in the thylakoid space continues to go up. And that is one of the goals here, that we're trying to create a concentration gradient, having lots of protons up here on the top in order to create that gradient, concentration gradient, where they're going to want to come back to the stroma to balance this out, because there's going to be an imbalanced amount of protons on one side of the membrane compared to the other side of the membrane. So you can see that we still have a water molecule over here that needs to be moved. We still have a NADP plus that needs to be used up. We've got some stuff to do here, so let's finish this off. So the next thing that's going to happen is that a photon is going to come down, another photon from light's going to come down and hit photosystem 2, and that's going to cause the splitting of the water. That's going to give the energy that's needed in order to move one of these electrons from the water through photosystem 2 and makes its way into the electron carrier PQ, and the proton from this is going to be released into the thylakoid space, and this electron carrier is going to essentially just kind of wait here until the next photon of light comes through and strikes the photosystem, which is going to cause the last of the electrons here to be released from water. Water is completely split now. Our two oxygens are sitting there. They're going to be released in just a minute. So the electron gets carried over and dropped into the electron carrier. This proton is, just like the rest of them, is released into the thylakoid space where it's going to wait. These two oxygens are going to combine, and this now becomes O2. This is oxygen gas that we breathe, and that is released as waste and leaves the plant. Okay. Now these electrons are being carried over to this cytochrome complex here, the proton pump, and in the process they get picked up, or the protons get picked up, just like the last one. They get taken to this proton pump. The protons are picked up and pumped to the thylakoid space one at a time. This electron then is going to be picked up, moves through the membrane here, through the cytochrome complex here, and gets picked up by our electron carrier, this next electron carrier, which is PC, gets carried to photosystem 1. At photosystem 1, another photon of light comes down and strikes photosystem 1, and that photon is going to give enough energy to the electron now that it can be passed through photosystem 1, where it's going to be picked up by ferredoxin, another electron carrier. This electron carrier takes it over to FNR. At FNR, it gets dropped off and it's held there. The ferredoxin moves back. The electron carrier PC moves back. The next proton gets pumped out into the thylakoid space. This electron is moved through the pump to the carrier, the electron carrier PC. I should mention the energy in order to pump this proton through here is coming from this electron as it passes through this complex. All right, now we're going to have a fourth photon come down and strike but I lost my other photon, so we're going to use one of these guys over here. Just take one of these guys over here so that we have the fourth one hit here. All right, and now this gives the energy that's needed to the chlorophyll in photosystem 1 in order to pass the electron to the electron carrier ferredoxin. Again, we're giving that boost of energy that the electron needs in order to pass through here. Now the electron carrier carries this electron over to FNR, where it's going to convert NADP+ with the addition of this other proton here, and takes the electrons and combines them into NADPH. Alright, so by this time you can see we've got lots of protons up here. If we were to continue this, we'd have lots of water molecules on the top here, all being split by continuous photons of light that are coming down, and protons that are continuously being pumped up into the thylakoid space from the stroma, and this process is constantly going on. We just showed it with two water molecules being split in order to show the concept of these NADPHs being made and the proton gradient being created here, and one set of oxygen molecule here, one oxygen molecule of gas being released. But keep in mind that this would be happening constantly, and there'd be like these things would be moving through here very quickly, and it would just keep constantly happening. Now, again, the goal is we're trying to get this protons to be built up on this side in order to create an unequal balance where they want to move back across the thylakoid space, across the membrane, in order to get back into stroma. But there's only one way for them to go. They have to go through ATP synthase, which is an enzyme that's not shown in this model, but we're going to talk about that later. Alright, so now as we've got this proton gradient here and these protons want to move across, that's the next stage that we're going to be talking about later. We've got our molecules that are ready to go on to the next step, which is the Calvin cycle. These are our energy molecules that are going to help with the next phase of photosynthesis to make glucose. So back to our summary is that we've got two water molecules were split. There was 4 photons here. I had to steal a photon for the model to get over here, but there's 4 photons here and there's 4 photons here to split 2 water molecules. 1 oxygen molecule of gas is released as a waste product. 8 protons got pumped into the thylakoid space from the stroma, combination of the stroma protons and the water protons. And then 2 protons from the stroma were used to make our NADPHs.